Welcome, scholars, to Unit 6 review for the unit of exponential functions. First, we're going to start by reviewing 6.1, properties of exponents. Number 1 says to simplify to a single power of 4. Since this is division, we're going to use quotient of powers property, which means we're going to keep the base the same and subtract the exponents. 4 minus 3 is 1. So our answer is just 4 to the 1 power, or just 4. For number 2, we're going to simplify to a single power of 2. Since we are multiplying, we're going to use product of powers property, which means we're going to keep the base the same, and we're going to add the exponents. So 2 plus 4 is 6. So my answer is 2 to the 6th power. For number 3, this is power to a power. So we're going to use power of a power property. So that means we're going to keep the base the same as 4, and we're going to multiply 0 times negative 6. 0 times negative 6 is just 0. Then we're going to use the 0 exponent property, which means for any non-zero number, a to the 0 is equal to 1. So 4 to the power of 0 is just equal to 1. And for number 4, we have another quotient. So we're going to use the quotient of powers property, which means we're going to keep the base the same as 6. We're going to subtract negative 2 minus 0. Negative 2 minus 0, or anything minus 0, is just itself. So that would be negative 2. And then we're going to use the negative exponent property, which means it's going to be the reciprocal of that exponent. So 6 to the negative 2 is the reciprocal of 6 to the 2. So it'd be 1 over 6 to the second power. And 6 to the second power is 6 times 6, which is 36. So it's 1 over 36. Oh, sorry, 3 is B, I never marked that, and now 4 is A. All right, I'm going to move on to the next page. So at number 5, we have a multiplication. We also have a power to a power. We're going to do the power to the power first, which is this part right here. So I'm going to write 4 to the negative 1 still, keep that the same, and then apply my power of a power, which means I'm going to keep my base as 4 and multiply negative 3 times negative 1. Negative 3 times negative 1 is positive 3. So I have 4 to the positive 3. Now that I have multiplication, I'm going to use the power of products, which means I'm going to keep the base the same and add my exponents of negative 1 plus 3. Negative 1 plus 3 is positive 2. And 4 squared is just 4 times 4, which is 16. So that would be B. All right, for number 6, again, we have 2 different things. We have a quotient and we have a power to a power. We're going to do the power to a power first. So that would be 3 times 2. Keep this down here the same. Let's separate this. All right, so 3 times 2 is 6. And then I have a quotient, so I'm going to subtract. So 6 minus negative 4. 6 minus negative 4, I'm going to keep change to give me 10. So my answer is 6 to the 10th power. All right, going down to 7. If I have a variable, I'm going to keep that variable as a B. And then this is a product, so I'm going to add the exponents. 4 plus 3 gives me 7. So it's just B to the 7th. And then with a power to a power, I'm going to multiply. 2 times 3 gives me 6. Now for number 9, I'm going to multiply my coefficients, which are 8 and negative 8. Coefficient is just the number in front of the variable. And then I'm also going to multiply my powers. So I'm going to add 3 plus 4. So 8 times negative 8 is negative 64. And when I add 3 plus 4, I get 7. So my final answer is negative 64, k to the 7th. And now finally I have a power to a power. So I'm going to say 4 to the 3rd times, or sorry, this is actually a power of a product, which means I'm going to break it up into 4 to the 3rd and then s to the 3rd to the 3rd. So I've just broken up what's inside, and both of them are to the power of 3. And now 4 to the 3rd power is 4 times 4, which is 16, times 4 again, which is 64. Let me show that over here. So 4 times 4 times 4 is 16 times 4, which is 64. If I break up 16 into 10, 10 times 4 is 40, 6 times 4 is 24, 40 plus 24 is 64, or use your calculator. And then power to a power would be 3 times 3. That gives me 9. There we go. So that is it for 6.1, and we're going to move on to 6.2. So with that lesson, we analyzed linear versus exponential. We said that if it was a linear function, to grow, it would be adding, and to decline, it would be subtracting. And for an exponential function to grow, it would be multiplying. And for it to be declining or decreasing or decaying, it would be divide. So let's look at 11. Which of the contexts below could not be modeled by a linear function? So could not be modeled by a linear function would be, it has to be exponential, should be multiplying or dividing. So a sunflower growing at a rate of 2.75 inches per week, that would be adding. Avani put $75 a month into a savings account, that would be adding. A town's population growing at a rate of 2.9% every year, that would be multiplying. And then taxi charging a flat fee, then another fee per mile, that's still adding. So for it to be an exponential function, it would be multiplying, it would be a C. And the reason why it's multiplying and not adding, because it's growing at a rate. Adding would be adding the same amount every time. But when you're growing at a rate of 2.9% every year, that number changes. So that's why it's multiplying. So for number 12, which of the contexts below could be modeled by an exponential function? So this is the same thing. So multiplying or dividing. So an amusement park charging $250 to go on each of the rides, that's adding. The sunflower growing again, that's adding. Snow melting, that's subtracting. And then the town's population grows at a rate of 7% every year. So these are very, very similar. I did not mean to do that. But on the test, it could be anything, right? It could be linear, not linear, exponential, not exponential. Just look for those keywords, try to identify the operations, and then go from there. All right, for number 13, we are graphing, which means we are going to first identify the asymptote, which in this case would be -4. So y equals -4. And I'm going to draw a dotted line, a dashed line at -4. At y equals -4, not x. All right, then I'm going to choose the points I'm going to plot, points that will fit from 10 to -10. So it looks like these right here are going to fit. Then I go ahead and plot it. So 5, -3 would be here. 6, -2 would be here. 7, 0 would be here. And 8, 4 would be here. So now I'm going to draw a curve through those points. And then I'm done. On the test, it is going to be multiple choice. You're going to have to choose. It might even be true or false. We'll see. Basically, just look at the points, make sure the points match up, look at the asymptote, make sure the asymptote lines up. Again, you're not creating it yourself, you're just choosing one. So just make sure the asymptote and the points match up with the one that you choose. All right, and then we're going to move on to 6.3, which is exponential growth and decay. So first, we're just setting up the equation. I know it's a little blurry up here. I tried to make it the best I could, but if you need to, refer back to your notes, and then you'll be able to see. Actually, you know what? I'll even just write it out for you. So y equals a1 plus r to the t. That's that one. It was a little fuzzy. And then y equals a1 minus r to the t. Okay, so hopefully now you can see that a little bit better. All right, so now let's look at 15. A radioactive compound with mass of 390 grams decays at a rate of 29% per hour, which equation represents how many grams of the compound will remain after 8 hours. So first step, I'm going to just write my function. Since this is decaying, I'm going to use my decay formula, which is y equals a1 minus r to the t. Then I'm going to look for three things, right? A, R, and T. A standing for my initial amount. So my initial amount is 390. Then I'm going to look for R, which is rate, and that would be 29%. Then I'm looking for time, which is 8 hours. So let's write it over here. So A is 390. R is 29%. T is 8. And then we want to change the rate to a decimal. So 29% is 0.29. So now I'm going to fill these things in. So A is 390, R is 0.29, and time is 8. And now I'm going to go in the middle here. What is 1 minus 0.29? In the middle of the parentheses, that would be 0.71, right? 100 minus 29 is 71. Now, since you're matching up, it might not be the same, but yep, it does look exactly the same, which is letter C. So if it doesn't look exactly the same, that means they probably did something like this, like letter D, where they just repeated it, or they just didn't add in the middle. You have to make sure yours matches up because these are multiple choice. All right, and going down to 16, since the town's population is growing, that means I'm going to use my function or my formula of the plus. So 1 plus r to the t. And so my let's label first. So initial amount is 77,000. My rate is 3%. And my time is 5 years. And so now I'm going to plug in. I don't always have to write it down. I'm just going to skip that step, but that helps you. You can write down ART to the side. So A is 77,000. 1 plus does not change, and that rate of 3% is going to be 0.03. And time is 5. So see, I'm just plugging these numbers into my formula. That's it. And now I can go ahead and simplify inside the parentheses. 1 plus 0.03 is 1.03. And now I'm going to see which one that matches up to. And it looks like that would be letter C again. So just be careful when you're looking, because see how that last one, it's to the third power. That's why that's not it. For B, it's 0.03, not 1.03. So that's why that's not it. And A, they were subtracting. And this is growth, so that's not it. So try to, write the formula first, like fill in everything, and then look at your answer choices. That's my suggestion. And now for 17 and 19, there's no 18, we're going to actually solve it. So the same steps, so I'm going to write my function. This is decaying, so I'm going to use the one with the minus in it. And 420 is my initial amount. My rate is 11.8%, and time is 16 minutes. If you're wondering how I'm doing this so fast, right? My initial amount's usually in the beginning of the question. My rate is always that percent. And time is always going to be minutes, days, months, weeks. whatever time is, okay? And then now I'm just going to fill in. So my initial amount is 420. My rate needs to be as a decimal, so 11.8%. 11.8% is 0.118. So I'm going to put in 0.118, and then t is 16. And now when I use my calculator, I'm going to put in 1 minus 0.118, and I get 0.882. And then again, when I use my calculator, there's certain steps now. I have to do this exponent part first and then multiply. So I'm going to just set this up, y equals. Now in my calculator, now you guys can't see me, but just follow along here. In your calculator, you're going to put in 0.882 to the 16th power. That gives you a long number. It's going to be 0.134121117. It's going to keep going. I'm going to just hit equals, and then I'm going to multiply that by 420. And since I'm rounding this to the nearest tenth, this is going to be 56.3. Okay, that is my answer. I'm going to go on to 19, there's no 18. And now this time, since dollars are being placed in an account with an interest rate, that's going to be growth. So it's going to be y equals a 1 plus r to the t. My initial amount is 3,600. My rate is 9%, and my time is 25. So my initial amount, 3,600, goes for A. The rate of 9% needs to be 0.09, and my time is 25. I'm going to do the parentheses, 1 plus 0.09, oops. 1.09, there we go. And now I'm going to use my calculator for the rest. 1.09 to the 25th power. Hit equals and leave that there. Then, you don't have to write it down. Then you multiply times 3,600, and that gives you a lot of money, $31,043. I can't forget the hundredths place because it's to the nearest cent. So that would be 0.09. And that's how much money is left after 25 years. And that is it. So, I know I went a little fast, but that's the whole point of the video. You can pause, rewind. If you rewatched it and did all of that and you still don't understand, please come find me and I will help you. We are taking the test next class period, and good luck. Oh, you are now moving on to the practice test. It's your choice to either do the paper one or the digital one. It's up to you, but you need to do one of those now that you've copied the study guide. All right, scholars, goodbye.